Related rates, everybody's favorite. So here's the big thing I want you to remember, Wiggy. Okay, just as a reminder, F is what you're trying to find, which is usually d something over dt. And the d part here is the rate of change of whatever this is with respect to time. The when is typically just a one-dimensional, radius, height, something like that. Given is anything else they give you in the problem, usually another rate. And your equation is either something they give you or something that you have to come up with, but then you derive that equation. So let's just get into an example. So here's on one. This doesn't really seem to be like a related rates, so that's why I wanted to work it, because I want to there's a few of these on here. When x equals 8, the rate at which the cubed root of x is increasing, so we may want to rewrite that, is 1 over k times the rate at which x is increasing. Okay, so basically, we got to figure out what are these two rates. Okay, this is just derivative. All right, so what is the derivative of f of x? So f of x is 1/3 x to the 1/3. So what would that derivative be? 1/3 x negative 2/3. Okay, here's my other function. We'll call it g of x, and that's x. So what is g prime of x? Well, that's just 1. So this is saying when x equals 8, so I'm not even really doing Fwiggy here. Probably when you do this, you won't even really realize it's a related rates problem if it wasn't on this packet. So when x equals 8, so we plug that in now. This rate is 1 over k times that rate. So here's what I'm going to do. I'm going to go 1/3 8 to the negative 2/3 is equals 1 over k times 1. All right, so I just need to figure out, okay, what is this? So that negative just means we put it in the denominator, the cubed root of 8 squared. That should be the same as 1 over k. So I got a couple things. I need to simplify this. Cubed root of 8 is 2, 2 squared is 4, and I could cross multiply, or I could just look at this and go, you know what, k has to be 12. There you go. Okay, let's look at 2. Radius of a sphere, blah, blah, blah. Let's look at our find when given and equation. Looks like they give us some equations. So, at the instant when the surface area becomes 100 pi square inches, what is the rate of increase in cubic inches per second of the volume? We're trying to find dV over dt. And it says rate of increase, so that should be a positive. What else did they give us? They told us that the radius was increasing, dr over dt, at a rate of 0.3 inches per second. Okay, in our equation, we have two equations. Now, since I am actually trying to derive volume, I am going to start with v. Okay, 4/3 pi r cubed. So I need to take derivative of both sides. This is your more typical related rates problem. So dv over dt, 3 times 4/3, that's 4. And then don't forget dr over dt. This is like implicit differentiation or chain rule. Okay, so since I'm looking for dv over dt, I should just be able to plug in and crunch the numbers. Problem is, I don't know r. I know dr over dt, though, is this value. So what have I not used yet? Okay, well, I haven't used this and this. So let's set them equal to each other. 100 pi equals 4 pi r squared. If I divide out the 4 pi, I get 25 equals r squared, so r equals 5. So I could put 5 here. I could have also just noticed that that was r squared and plugged in 25. This is a non-calculator, so 25 times 4, that would be 100. 100 times 0.3, if I just write this out, we just move the decimal over 2 places, and that makes 30 pi. There you go. Okay, you're going to do 3 on your own. You're going to do 4 on your own. One quick thing about 4 is that your equation, I'm going to go ahead and tell you, is x squared plus y squared equals z squared. And when you derive it, you're still deriving with respect to time. See all these over dt's? So you get 2x times dx over dt plus 2y times dy over dt equals 2z times dz over dt. And now plug in everything. If there's something that you don't have, you might need to use Pythagorean theorem to find it. Okay, you'll finish that one on your own. 5, you'll do on your own. That's a shadow problem. You may need to look that up in your notes. I'm not going to do that in this video, though. 6, you get to skip. Okay, 7, you're going to do on your own. 8, you can skip. Okay, 9, we had one similar to this in an after party recently. 9 and 10, you're going to do on your own. Okay, 11, let's do this one. This is a free response one. So, oil leaking on a pipeline. Okay, this sounds like a problem we've done before. Constant rate of 2,000 cubic centimeters per minute. That per minute tells me that this is d something over dt. And the context tells me. I can see here that that's the volume. The shape is a right circular cylinder, and radius and height is changing. Not necessarily in proportion, though. We don't know that. The volume, they go ahead and give us that equation. And so it says at the instant when the radius is 100 centimeters and the height is 0.5 centimeters and the radius is increasing 2.5 centimeters per minute, another rate. At this instant, what is the rate of change? So here's my find. What is the rate of change of height in the oil slick with respect to time? Now, I do not know if this is plus or minus. I don't know that. Okay, when, it says at the instance when the radius is 100 inches and the height is 0.5 centimeters. Sorry, I don't know why I wrote inches there. That was weird. Centimeters. And the radius is increasing, so dr over dt is a positive 2.5 centimeters per minute. Okay, what else were we given in the problem? Well, we were given this volume was increasing at 2,000 cubic centimeters per minute. All the units are lining up nicely. And then our equation, they give us to be V equals pi r squared h. Okay, so I'm going to write this one more time over here, and now I need to derive it. I can't plug in anything for RH before I derive. Okay, and this is not a cone problem where you have some proportions. So I need to use product rule on the right side. I'm going to think of it as these are the two pieces. What is the derivative of pi r squared? 2 pi r. dr over dt. That's the derivative of pi r squared. Now, times just h, plus just pi r squared times the derivative of h, which would be 1 dh over dt. Okay, dv over dt, we know that to be 2,000, so I'll go ahead and plug that in. Okay, do we know r? We do, it's 100. Do we know dr over dt? We do, it's 2.5. Do we know h? Yes, 0.5. Plus pi r squared, so 100 squared, and dh over dt is what we are looking for. Okay, so one quick thing, I'm going to pull the calculator up because this is where a lot of people make mistakes here. You can use the solve feature. I'm going to clear my variables just in case. I'm not sure what I was doing last. Okay, but what you have to remember is that if you solve this algebraically, you got to do 2,000 minus all of this and then divide it by pi times 100 squared. Okay, you can't do all of it. See that plus right there? Okay, we got to subtract. I'm going to type it in. 2,000 minus 2. Use the pi symbol. 2 pi times 100 times 2.5 times 0.5. Okay. Then divide all that in parentheses by pi times 100 squared. Now, this is already giving me a decimal. If you're like sure you want a decimal, you could do diamond enter, but it's going to give me a decimal. Okay, and so then dH over dt would equal point, so that's inconvenient, 0.039. And what are my units? Centimeters per minute. Okay, you could have used the solve feature as well. That would have totally been okay. Okay, just make sure that you are solving for what you really need to. Don't forget your algebra skills.